Okay, for our next example, this is going to be an example of your fourth integration formula on page 286, just showing us that we have two separate functions. So what we are allowed to do when we have two separate functions or separate terms, we can separate this and integrate each piece individually, which actually makes it really kind of nice because it simplifies our whole process. Because now we can look at the antiderivative of x and then the antiderivative of 2. So to take and differentiate, or anti-differentiate, I got to get myself used to saying this, we are going to use the backwards of the power rule, which means I'm going to take x, instead of subtracting the exponent, I'm going to add it, and then divide by the result. And then I have my plus c. The antiderivative of 2, we're going to add that to that result on that. That's just a constant, so 2 times some x, essentially that's x to the first divided by 1, plus some other value of c. Now, looks like there's two c's on our answer, but a constant is a constant, so it doesn't matter. We only need to use one of the c's. So our final answer in this one would just be x squared over 2 plus 2 over x, or sorry, 2x plus c. Again, we don't need to have multiple c's. We don't know what c is, but when you add c to c, you still get some random constant. 6 is very similar to 5. Instead of having two terms, now you've got a three-term polynomial, which no big deal. Then we just break up each individual term, and we're going to do the integration of each individual term. If I'm smart about this, which I wasn't when I first started this one, I would have recognized these as constants, and I can pull those out right off the bat as I rewrite. So that negative 5 can come out here. Oops, and I'm forgetting my dx, kind of important, plus x dx. Because if you're going to break these up, having those dx's there again is important. It may seem insignificant, but it is indicating that you understand what calculus you are applying, because we're doing the integration with respect to x. So my constant gets to stay on the outside. Power rule backwards. So I'm going to add 1 to this guy right here, divide by his result. Then I have my negative 5. I'm going to add 1 to this and divide. I'm going to add 1 to this, divide, and of course, don't forget your plus c. Looking to see, do I really have anything to simplify in this one? Nope, this one kind of simplifies quite nicely. And that's as good as she's going to get. Alright, 7. We've got rewrite, again, integrate, and simplify. So I'm going to break this up into two separate integrals, just as like I've been. I'm going to pay attention to these constants that are there. That'll make my life a little bit easier. So I'm going to make this 2 x squared dx. And then I'm going to take this 2, yep, he can come out here. He becomes 1 over x squared dx. But then I've got this. Not ready to integrate that as is. I want to rewrite it. I want to rewrite it to get it in terms of a power if I can, and very easy to do so in this case. So I'm going to just rewrite this. Keep that 2, and now he becomes x to the negative 2. Now it's actually relatively easy to integrate. All we're going to do is make sure we add on to our exponents. So I'm going to keep my constant out here, add 1 to the exponent, divide, keep my 2. I'm going to add 1 onto this exponent. This time it makes it negative 1. Don't forget your plus c. Looks like a great answer, but you're not completely done because we have to make sure we don't have any negative exponents in our final answer. That's the simplified portion. So that 2x cubed over 3 is fine. That negative and this negative here are going to cancel each other out. That's going to leave me with a positive. That 2 is going to stay in the numerator, but your x to the negative 1 is going to go to the bottom, plus c. Our final example, yep, negative pi, he's a constant, so I'm going to pull him out in front. That becomes 1 over x dx. And then I come over here and I go, all right, I'm going to rewrite that again before I try to do anything. That becomes negative 1 dx. Integrate. I'm going to add 1 to that, and that becomes 0. And I hope you're all looking at this going, well, what in the world am I supposed to do with that? Well, you didn't do anything wrong. You just weren't paying attention to some of your derivative rules if you got to this point. And one of your derivative rules means that you should recognize as 1 over x as a special value. If you look at the very last line of your integration formulas on page 286, you'll recognize that this is natural log of x. So your final answer actually should be negative pi natural log. Yes, we put the absolute value in there because we can't have an absolute or an x value that's going to be negative plus c.